Have you seen this one? You're scrolling online and you see a video that just seems to break reality? Well, today we're going to crack the code on one of those viral internet mysteries. And the craziest part? It all comes down to a simple object you definitely have in your house: a mirror. So here's the big question that's got everyone online so confused. Can a mirror actually reveal something that's supposed to be hidden? I mean, can it somehow peek around a corner or see through an object? Logically, you'd say, no way. But then you watch these videos and the answer seems to be, yeah. And it is very, very weird. And this whole thing has been dubbed the viral mirror glitch, which is where we're going to start. And honestly, this quote from a Reddit thread just sums up how everyone feels when they first see it. What basic physics is this that I don't understand? It's the perfect question. Okay, so here's the setup, and it's super simple. Someone takes a piece of paper and holds it up to a mirror. Then they hide a small object, like a chapstick, right behind the paper. Now, from your point of view, you can't see the chapstick at all. It's totally blocked. But you look in the mirror, and bam, there it is, clear as day. As one user, Code Possum, put it, everyone reacts like it's some sort of black magic. And you know what? It really does feel that way. All right, let's dive in, because this isn't magic, it's physics. And to solve this whole mystery, we just need a few really simple rules about how light works. Let's think of these as the clues that are going to unlock this entire illusion. It really just boils down to three things. First, light travels in straight lines, period. It doesn't curve around stuff on its own. Second, light bounces or reflects off of things. That's pretty much how we see everything. And third, and this is the big one, it bounces in a super predictable way. The angle it hits a surface is the exact same angle it bounces off. Now, this third rule has a fancy name, the law of reflection. Angle of incidence equals the angle of reflection. It sounds all technical, but it's not. The best way to think about it, and somebody on Reddit came up with this brilliant comparison, is the classic video game Pong. The light is the ball, the mirror is your paddle. The angle the ball hits your paddle is the exact same angle it bounces off. No exceptions. Okay, so with those rules in our back pocket, let's get to the solution. The whole secret here is just a simple shift in perspective. It's not about what you see, it's about what the mirror, quote-unquote, sees. The reason this thing messes with our heads so much is that our own brains are tricking us. We're asking the wrong question. We're looking at the paper and asking, how can the mirror see what's behind the paper? But that's not what's happening. That's not where the reflection is coming from. So here's the crucial difference. From your eyes, yeah, the paper is blocking your direct line of sight to the object. It's blocked. But the reflection you're seeing in the mirror, it isn't coming from the part of the mirror behind the paper. It's coming from a totally clear spot on the mirror off to the side, and from that spot, there's a perfectly straight, clean, uninterrupted line of sight to the hidden object. Light travels from the object, hits that clear part of the mirror, and then bounces, following the law of reflection, straight into your eyes. Simple as that. But okay. That brings up another question, right? If it's just basic angles, why does it feel so impossible? Why does our brain look at that and just go, nope, that can't be right? Well, it turns out the physics might be simple, but how our brain perceives the world is anything but. The reason it feels so bizarre is that your brain is getting two completely different sets of signals at the same time. It's a fight between where your eyes are pointing and where they're actually focusing. And there's a really cool name for this, especially in fields like augmented reality. It's called the vergence accommodation conflict. So here's the battle going on inside your head. Vergence is basically your eyes turning inward or outward to point at something to judge how far away it is. They see the reflection and they try to point to where the object seems to be, which is way back behind the mirror. But accommodation is your lens changing shape to get a sharp focus. And to get a sharp image, your eyes have to focus on the flat, physical surface of the mirror itself. So your brain is getting one signal that says deep and another that says flat. That conflict is what creates that weird, impossible feeling. You know, this entire illusion is only possible because of this one piece of technology we totally take for granted. But the story of how we even got a perfectly reflective mirror is actually pretty fascinating. For the longest time, making a good mirror was this really dangerous art. Back in the 16th century, artisans in Venice were using this toxic mix of tin and mercury. It wasn't until 1835 that a chemist named Justus von Liebig figured out a safe way to put a super thin layer of pure silver on glass. Then, fast forward to the 1930s, we get aluminum vacuum deposition, which totally changed the game for things like giant telescope mirrors. And today, we're using these unbelievably precise techniques for space telescopes. And here's something that might surprise you. The silvering on a mirror isn't always silver. What metal you use completely depends on what you're trying to look at. Silver is the best at reflecting the visible light we see every day, so it's perfect for the mirror in your bathroom. But aluminum is tougher and doesn't tarnish, so that's what you want for a telescope. And if you want to see in infrared, like the James Webb Space Telescope, you use gold. It's the best at reflecting infrared light. So that viral glitch, the one that looks like straight-up magic, it's really just this perfect intersection of really simple physics, some amazing technology that's been evolving for centuries, and the totally fascinating way our own brains try to make sense of the world. And that kind of leaves us with one last big thought. This whole trick shows how easy it is to confuse our brains with just a little conflict between depth and focus. So if a simple, flat mirror can create an illusion this powerful, what's going to happen when our reality is actively being augmented with things like AR and VR? What kind of new, mind-bending illusions are waiting for us right around the corner?